Right, let's start. So just so you know, if I'm looking like this, I'm looking at you. If I'm looking like this, I'm looking at my screen. All right. As I said in my announcement, we will do an Excel today. Now, it's not required that you do with me as is in the classes. So in-person classes, sometimes people do it with me, but sometimes they will just see how I do it. And I also want to encourage you to focus more on concepts than going over how to do stuff because I constantly put videos out where I explain the how to do stuff. So for all the technical parts that we do in this class, I'm going to post videos on that, right? And those are like shorter videos on just how to do this in Excel. And then you can use those videos for everything, like for your homework, for your classwork, for your exam, everything. Um, that reminds me, so today we are going to delve into regression, but I do want to talk a little bit about the syllabus and see if you guys have any questions, if you have looked into it, and just to let you know the structure of the class that I'm going to follow, or I'm going to try to follow unless it becomes online for a few more weeks, and then I may have to change, but of course I will let you know. So with that, let's look at the syllabus real quick. I think you should be muting your video unless you're speaking to me. Sorry, I just keep having people needing to admit. I'll have my TA be present next time so that he can admit people. Okay. So let me stop share and go back sharing my syllabus. All right. Have you guys looked into syllabus at all? How many of you have looked into syllabus? Okay. Do you have any questions? No questions. All clear. Okay. So just so you know, there's gonna be three kinds of assignments in this class, right? There's gonna be some classworks, which you will do in class. There's gonna be some homeworks, which you will do at home. And there's gonna be exam, which again you will do in class time. So there are 7 classworks throughout the semester. And then out of 7, I'm only gonna count the best 6 that you got. Okay. So that's the only thing that you can slip and not do one. However, for homework and exam, I'm gonna count all of those, right? So there's gonna be 4 homeworks. And in this class, homework carries the most amount of points, right? So homework is 41% of the class. And then classwork's gonna be 24% of the class. So each of the classworks that you do is gonna be 4 points each. And exams are only 30% of the class because I don't know, I do realize that doing well in exam also takes a little bit of luck. So it's gonna be only 30%. However, all my exams are going to be open book, open notes. It's just going to be timed, right? So you do have to study and prepare beforehand, but you don't have to remember anything. And that's true for in general for this class, that I don't want you to remember anything, right? Which is why I want you to in class, I want you to focus on the concepts, right? because you can always go back and look at the technical stuff from my videos or from PowerPoint or from the book and everything else. All right. And then I do have this 5 points for attendance and class participation. I'm gonna take attendance on and off. Um, I'm gonna take every day for the first 2 weeks because I'm required to. But I think these points you can think about more of it as like by the end of the semester, if I know your name and if I have seen you enough, I'm generally lenient with these marks. But then that also means that if I haven't seen you enough, I feel like I have never talked to you or not enough, then you're gonna get a reduced rate on that. Um, and then throughout the course, you will have, so although attendance is not, I'm not gonna take attendance every day, like I said, but I'm gonna pass it around from time to time, and then I will take like an average of that or something like that. But if you miss a class and that class has an extra credit opportunity, you're gonna miss that extra credit opportunity. And there's gonna be lots of I want to say lots, but there will be some extra credit opportunity that you can bump up your grade up to the one higher level, right? So and then this extra credits I'm gonna give them whenever like I see the class responding, right? So if I see the class is not doing very well, I might give more. If I see class is responding well, I might not give that much. So it kind of depends on how the class goes. And that's kind of my way of doing a curve, right? I'm not going to be doing any curves at the end of the semester. So all I'm going to be doing is extra credit because I believe that if you're getting a grade, you should earn it, right? So you have to do something for it. Some of you already got one extra credit, right? In this class, yes? Because I did ask you to look at the syllabus, and I said, if you have rated here, send me a picture of your favorite animal to receive an extra credit. So some of you did do that and got that extra credit, but again, there's going to be much more extra credits that I will be giving in this class. No worries if you missed that. All right. Any questions?
I've got a question. So if we've got a trip or something to go on, but it's not like a school sanctioned trip and we let you know beforehand, could we do our work before so that we're not getting anything taken off?
Yes. So I'm all for open communication, right? As long as you let me know beforehand, we'll make it work. Even if it's exam, I'll make it work. I just don't want you to not be here without any reason, right? So that's all. If you let me know and I give an extra credit on that class, I'm gonna send it to you and let you do it. So as long as you let me know and there is a valid reason, yes, you can get it. So another thing, and I hope that we convene in person sooner for that, at least next, I don't know, in next 2 weeks. So your classwork and homework assignments are going to be in groups. And you can choose to work alone, that's fine. But you have the option to do it in a group, right? Of course, it's difficult to pick your partner when you haven't met each other. So what I'm gonna do for your first classwork is to pair you up in random groups, right? Which is next Tuesday. It's going to be your first classwork. Now again, classworks, you don't really have to prepare anything beforehand because I will show you how to do it. I'll give you enough hints how to do it. And then whenever you're stuck, you can call me and I'll come help you. Okay? So it's more like practicing the thing that you learned. And I think it's been very useful in class so far, like all the feedback that I got, because you need to practice, right? In this class a little bit, you need to practice a little bit. Otherwise, you wouldn't know if you're not understanding or if you're understanding. If you're just listening to me, maybe it'll make sense, but then when you try to do yourself, it might not. And these classworks are going to help you to solve your homework, right? And then these homeworks are going to help you to do well in exam. So that's how I structure my class. So you go one by one. Um, so for first classwork, like I said, I'm going to put you in random groups. Now, if it's going to be online, then I'm going to just put you in random breakout rooms, unless you let me know beforehand you want to work alone for the whole semester. So If you want to just work alone for the whole semester, you are determined to that, you just email me and I'll make sure that I do that. So the groups are going to be 1 to 3 people, right? Of course, you can work alone, or you can be in a group with uh, one other person or two other people, right? So it's going to be from 1 to 3 people, and I think after we meet first time, hopefully next Tuesday, or after we do your first class assignment next Tuesday, I'm going to send out a sheet or ask you to email me with your group members if you have one. Right? So if you don't pick your group member and you don't want to work alone, you do want to. So if you want to work alone, yes, you get to work alone. If you want to work in a particular group, yes, I'll assign you to that. If you want to work in a group, but you don't have the group members, then you let me know that, or you don't do anything basically, and I'll assign you to a random group after everyone signs up. Okay? So that's how it's gonna work. Catherine, sorry, I'm sorry for calling you out, but if you want to work alone, anyone want to work alone, you have to email me, okay? I cannot take notes during the class. Just send me an email that I want to work alone, and I'll make sure to accommodate that. All right, any more questions? All right, so let me stop sharing. And then so does everyone have a Excel downloaded, like an Excel app, Microsoft Excel app in your computer? Some of the things are not going to work in your web apps Excel, right? So if you're just using Excel online, some of the things are not going to work because we do have to, not for, yes, for regression also, we will have to get an add-on that's not available in online version. So you do have to have an app. If you don't have an app, it is free through if you're through your University of Memphis account. And if you have any problem, just contact the helpline or write to me. I'll try to help, but I don't know, maybe contacting the helpline will be more help than myself. Right. So have you guys looked at my first video? At least some of you? Okay. Right. So today we are going to do a simple linear regression. Of course, I haven't told you anything about simple linear regression, so we're going to go into that. All right. So if you did look at my video, we are going to talk about different tools for business analytics in this class, right? And business analytics is like I said, is the scientific process of transforming data into insight, right? So in this class, you're gonna have different kinds of data. So this data might look like just a picture. Sometimes you'll see I'll just give you a picture and you have to optimize something in the picture. Data might look like long Excel sheets. Data might look like a story, but they're all data, right? And they're all asking you to derive some insight from that data. So in this class, you're gonna look at this data and use different analytic tools to get insight from that data, right? And these analytic tools going to be mostly predictive or prescriptive. So descriptive tools are something that I hope you have learned a little bit in your business statistics course, right? So it's mostly doing, let's say you want to get like histogram of data or some box plots of data. That's like really just looking at past data and understanding it, right? Um, we are sorry, what did I want? So we are not going to look at descriptive tools because we are older, right? And this is the advanced class, so we are going to do predictive and prescriptive tools, which means that we are going to predict the unknown, right? So this is the next step. Looking at the data, we are going to learn about tools that helps us predict the unknown. And based on that prediction, sometimes we are going to prescribe something, meaning that we're going to tell what to do to the manager. Um, and so first half of the class is going to be based on predictive analytics, meaning that we are going to learn two techniques, regression and time series analysis. Both of them has the same goal. They want to look at past data, and based on the past data, we want to build models. Now, whenever I say models, it's boring than what you think models are. So in this class, models means equations. Why are equations called models? Because if you have an equation, then let's say you have an equation y equals to 2x plus 3, right? So it's a model because for a particular value of x, you know the value of y, right? So given the values of x, you will be able to tell a value of y. So that's why it's a model, right? It's a model to build something. It's a model to tell something. So yes, whenever I say model, I mean equation. And you're gonna see one of the very simple model today. So this predictive analytics, I'm gonna generally for predictive analytics methods, there are qualitative methods and quantitative methods for, right? Now you can imagine we in this class, we are going to talk about equations, right? So which means that we're going to talk about quantitative methods. We're not going to talk about qualitative methods. But I do want to tell you a little bit about when qualitative methods are useful. So for example, let's say Apple is launching a new iPhone, right? And of course, they have some data about past iPhones. But in this case, qualitative methods are also useful. Why? Because historical data for this particular iPhone, you cannot get that, right? So they are unavailable. So they would do some surveys, they would go some focus group experiments and things like that to get how actually consumer will react to this iPhone. And these are all qualitative methods because these are like they're interviewing people, they are getting some expert opinions and things like that. Now, one problem with these methods are that they are highly subjective, right? So it depends on what focus group you're interviewing to or what manager you're talking to, which means that they cannot be very reliable. They can be base of our understanding, but they cannot be super reliable, which is why we need quantitative methods, right? So in this class, we are going to talk about two kinds of quantitative methods for predictive analytics. One methods that we're going to use are called these causal models. Oops. So in regression, and the first analytics tools that we learn, which is regression, is going to be a causal model. So what is a causal model, right? So a causal model is that we are going to create a model to describe a relationship between two different variables. Okay? I'm going to give you examples so that it becomes clear. So the model or the tools, the analytic tools we will use is that we want to understand something, but we will understand that based on its relationship with something else. Okay, so that's kind of the main model, and you'll see lots of examples. Then we will also do time series model, where we are not establishing any relationship. However, you just have data for historical values of our past data, right? So you're going to observe a pattern in past data. And based on that pattern, you are going to be able to predict the future value. So that's the main difference between causal model and time series model. Right? So causal models are you're trying to establish the relationships between two variables. And time series models are going to be that you just have some historical data and you are trying to find a pattern in the data over time. And you're just going to extrapolate that pattern and predict the future based on that pattern. Okay? Any questions so far? All right. So I do have a book in the syllabus, right? However, it's recommended, not required whatsoever. I would say the book is only useful if you are having trouble understanding me and we have like secured office hours multiple times, but you don't really understand like how I speak or my language. It's just Hebrew to you, so maybe that's when the book could be useful. Or if you want to get some extra practice, maybe. But again, if you have it, it's great. But you don't need to get out of way to buy it, I would say. But it's a good book to have. So if you have the book, then I think regression is in chapter 7. And yes, I will be following the book at most of the places in this class. And some of the times I'm just gonna follow my brain, right? And just come up with random examples that I think would be useful for this class. All right. So as I said, we are gonna do regression today. And regression is one of the causal models, right? So in this class, in the in-person class, I generally give a 5-minute break in between. So I'm gonna do that in this class as well because it's a 1.5 hour class and it's long to sit down. If you guys feel already tired, just raise your hand and I'll know that's the time. Otherwise, I'll give it in my hand. But if you guys feel like it's too much and you need a break, just raise your hand. And you have the raise hand option, right? Can anyone raise your hand? Okay,
Are
cool.
you like asking for the reaction?
Yes. Yes. Yes, yes. I got it. Thank you. Yep. All right. So, um, regression is what? Regression is okay. So regression is one of the causal models that we talk about, right? Which means that our focus is going to be understanding relationships between two different variables. And based on that relationship, we are going to build a model. Again, by model, I mean equations. And then we are going to use that model to predict an unknown. Okay? We'll see how that goes. But first, let's talk about relationships. What do I mean about relationship between two variables? So let's guess what the relationship between the following pairs of variables. So what do you think is the relationship between weather temperature and ice cream sales? So when I say relationship, what do you think, how do you think they're related, right? So if weather temperature increases, do you think ice cream sales in a particular area would increase or decrease?
Greece.
Increase. Increase.
Increase, right? So that's the relationship, right? So the relationship is that they have an increasing relationship, right? So these two variables are related. How about social distancing and COVID-19 infections based on scientific papers, right? So what do you think? If social distancing increases, does COVID-19 infection decrease or increase?
Decrease.
Decrease, right? So that's the relationship I'm talking about. What do you think is the relationship between price of a gallon of milk and number of car accidents that happens in the road beside that supermarket? Is it increasing or decreasing?
There is no correlation.
Exactly. So there is no relationship. Right? Very good. So now you know what I mean by relationships. Right? All right. So this is relationship we understand because these variables we know about them, right? So every day we bump into them and we know about them. However, there's going to be variables that we don't know about. And to understand the relationship between those variables, the first thing we would do is a scatter plot. Okay? And I'm going to show you today how to do a scatter plot. So the scatter plot of are going to look something like that, right? So if you see a scatter plot like this between two variables, that means there is an increasing relationship. So if you plot ice cream sales and weather temperature, you're going to get a scatter plot like this. If you plot social distancing and COVID-19 infections, you're going to get scatter plot like this, which is decreasing. Right? So we understand what is increasing and what is decreasing from scatter plot. Right? So this is increasing. The first one is, you guys see my mouse, right? Like my arrow. You guys see my arrow? Okay. So it's increasing. This is decreasing. Now this is linearly increasing. We're going to talk more about that. Maybe we can not talk about that right now, but just so you know, we're going to talk about linear regression as well as nonlinear regression. So when we talk about nonlinear regression, am I speaking too fast? You guys will let me know, right? Okay, thank you. All right. So we will say nonlinear relationship sometimes. It just means that the way it increases is not linear, right? So this one is non-linearly increasing. So it first increases in a faster pace, then it increases at the end of x, right? So this is a non-linear relationships. So if you can probably tell English is not my first language, so sometimes I'm gonna think about the right word to say, and sometimes I will probably come up with my own word that doesn't exist. So if you don't understand, you have to let me know, hey, Punya, that word doesn't exist. Explain, right? Also, I would really prefer that you call me by my name. I like that way, but it's up to you. But my name is Punya, and I would really like for you to call me by my name, if you could. Sorry, a little bit of I digress, but let's come back. So now if you look at this, right? So this is an example of no relationship. So that would be like price of milk and number of accidents, right? So there is no increasing or decreasing any relationship. It's just scattered everywhere, right? So that's going to be no relationship. All right. Any questions so far? Okay. So what is regression analysis? Now we understand about relationships. So how do we relate to regression, right? So what is regression analysis? Now regression is used in every managerial decision that's been made in this world, right? It's the most used analytic tools. And I guess like at least half of the class has seen regression before, right? You have seen regression. Some of you have seen regression before. Okay. So hopefully it's gonna be an easy peasy section, but I'm gonna go a little bit deeper, right? This time. Throughout the classes. So as I said, regression is based on relationships, right? So that's why I say that managerial decisions are often based on relationship between two variables, just like we talked about relationships, right? So sometimes a manager will rely on intuition to judge how these two variables are related. And if we can get data for both of these variables, then we can perform something called regression analysis to solidify that hunch that manager has. Right? So we can say how well these two variables are related, or develop an equation of how they're related, so that if we get, let's say, we can predict one of the variables based on other with that equation. And then we'll see how that works in this class. Now in regression, the most important things that you will learn, and this is something that you have to do in every question that you answer in this class, right? In regression, you have to figure out what is the dependent variable in this question and what is the independent variables in this question. Okay, these are the most important things that you will learn that you have to use every day in regression. So what is dependent variable? dependent variable, as the name suggests, is the variable that depends on something else. So we are only talking about two variables, right? So the variable that you are interested in, the variable that you are predicting, the variable that is dependent on other variables is called dependent variable. Independent variable is also called the predictor variable. That means that these variables are used to predict the value of the dependent variable. I'll give you examples so that it becomes clear, right? But just so you know, so all the time, we are gonna call dependent variable y and independent variable as x. So whenever we write the equation, sometimes I'm probably gonna write y equals to something x plus something. That means that y is the dependent variable and x is the independent variable. Okay? But you'll get used to it, I think, eventually. All right. So let's talk about dependent and independent variables, right? So let me explain the first one and maybe you guys can help me with the rest of them. Okay? So let's say you are, or your manager is asking you to predict this year's ice cream sales based on the forecasted weather temperatures. Okay? So you are trying to predict the ice cream sales based on the weather temperatures. So what are you trying to predict? Ice cream sales, right? So whatever you're trying to predict, that's going to be the dependent variable, right? So in your regression, when you do regression, you have to tell Excel what's your dependent, what's your independent. So you have to tell Excel that if you have data on both ice cream sale and weather temperature, you have to tell Excel that ice cream sales is the one that is dependent. And what are you predicting your ice cream sale based on? That's your forecasted weather temperature. So that's going to be your independent. Okay? So the weather temperature does not depend on ice cream sales, but ice cream sales depends on weather temperature. Okay? So that's the one way to remember it. So ice cream sale depends, that's why it's going to be dependent. Weather temperature does not depend, that's why it's going to be independent. Any questions? All right, so let's do the next one. How does the spread of COVID-19 infection depend on average social distancing in a society? In this question, what is your dependent variable? I would prefer if you just speak up than
The
write it in the
spread.
chat. Yes, the spread is the dependent, right? Because spread is what depends. Right? What is the independent variable?
The average social distancing.
Right. So the social distancing does not depend on infection, but the infection depends on social distancing. Okay. And your dependent variables are the variables that often you are interested in predicting, right? For your managerial decisions. For example, you are probably interested in predicting ice cream sales because you're going to understand how to price the ice creams, right? So those are the things that you are going to be predicting based on weather temperatures. Okay? So how about the third one? Now, again, I know that there is no relation exist, but if there were, what would be the dependent variable based on the question? How does the price of a gallon of milk depends on the number of car accidents on that day? Because maybe the statistician is interested in understanding this relationship. And maybe with the regression, they will figure out that there is no relationship. But to do regression, what is going to be their dependent variable?
The price of milk.
Milk price, right? Because that depends. So that's the dependent and everything else is, and the number of cars is independent. Okay, so last one, predict demand of a product based on its pricing. What is your dependent variable?
Demand.
Sorry, I missed that. Can you say again?
The demand of the product is the dependent.
Yes. So the demand of the product is dependent and pricing is independent in this situation, right? Because you're trying to predict demand based on price. All right. So this is going to be base of all regression that you do. All the questions I give you, you have to first figure out what is dependent, what is independent. So are we feeling comfortable with that? Yes?
Yeah.
Okay, good, good. Thank you. Let's see the time. You know what? I'm gonna skip linear and nonlinear because maybe I'm gonna talk about it when it is not linear that we study. So we're gonna talk about two different kinds of regression, and today we're gonna talk about simple regression, and next class we're gonna talk about something like multiple regression. So what's the difference? In simple regression, you're going to have one dependent and one independent variable. Okay. All the examples we did so far are example of simple regressions because we had always one independent and one dependent. Now, throughout the course, we will always have one dependent variable because that's something we're interested in, that's something we want to predict. Our focus is going to be one dependent variable. And all the regressions that you do in your whole life going to be one dependent variable. You have to focus on one thing to understand that variable. However, more likely there's going to be multiple independent variables, right? So that's going to be multiple regressions. And there's gonna be, could be two, could be hundreds of independent variables. Because for example, think about more realistic condition. Let's say we talked about ice cream cells, right? So the ice cream cells, yes, it could depend on, or it could be based on weather temperature, but also maybe the humidity of the air makes it, sometimes ice creams taste better, right? So maybe, so in following ice cream cells, predicting ice cream cells, maybe the salesperson will look at both humidity and temperature. Right? And that will be a multiple regression because we have now two independent variables, humidity and temperature. And then one dependent variable, which is going to be the ice cream cells. For the pricing products, the demand might depend on pricing as well as, let's say, availability of the product. If the product is not available, then you are not going to be able to sell the product, right? So, or maybe I should say sales, not demand. So sales might depend on pricing as well as availability. So then it's going to be again a multiple regression because you have two independent variables. So next class onwards, we are going to jump to multiple regressions, doing regression with two independent variables. But for today, we just want to focus on basics and understand regression better. So we are only going to talk about one dependent variable and one independent variable. Okay. All right. I think I'm gonna take a 5 minutes break now. If you wanna just walk a little bit, get a coffee or anything. Because when we start, we're gonna look at our first simple regression model with some data. And in between, if you have some time, please download the Butler data that's available if you want to work with me together. If you don't, that's totally fine. Okay. Again, I'm gonna have videos available later. But if you do want to work with me, please download this data so that when we come back, we can work on this data. Okay.
Do you mind if we have our cameras off during the break?
Yeah, definitely. So I'm gonna be back on 10:26. All right. So throughout this class, whenever we learn a new tools, we are going to learn through an example. Okay, and so for regression, we are going to look at this example of a trucking company. And as we go, like next class, I'm just going to add more onto the data. So today's data, you will see very small data set, but next class, I'll add into more to understand multiple regression. And then next class, I'm going to add into more to understand inference and things like that. But this example is going to be base example that we're going to use throughout the regression. And we're going to do, of course, different examples through our classworks, or I'll give some practice examples and things like that. But in class, I'm going to focus on this particular example so that we remember this example, and then based on that, we understand the class faster. All right, so we are going to talk about this Butler Trucking Company, and we're going to start with something very simple, right? Now, this trucking company is a trucking company in Southern California, and a major portion of their business involves deliveries through the local area, right? So that's how they make money. Now, of course, because they are in the delivery business, they want to develop better work schedules, right? So they're doing faster deliveries, more efficient deliveries, and things like that. So the manager wants to estimate the total delivery times for their drivers, right? So how much total time the drivers are taking to make these deliveries. That's a very reasonable thing to ask for the manager. And what he believes, okay. So he believes that the total delivery times are closely related to the number of miles that they are traveling to make these daily deliveries. That's a reasonable assumption to make, right? So the total time that you take is going to be related with number of miles that you travel. Right? So in this question, what do you think is the dependent variable, and what do you think is the independent variable?
Number of miles is going to be the independent variable.
Exactly, very good. So number of miles is going to be independent variable because number of miles does not depend on the travel time, right? Travel time depends on number of miles. And travel time is something that the manager is trying to predict or estimate. So that's going to be the dependent variable. The travel time is going to be the dependent variable for this problem. And the number of miles is going to be the independent variable for this problem. Does anyone have any question? Do you want me to repeat? Does it make sense? Okay. So as I said before, I'm going to call x as the independent variable and y as dependent variable. Okay? So you can think about it, y it's x and y, you can think about it, y comes after x, right? So y is the dependent because it depends on something. The independent comes first, which is x, and then comes y, xy, right? In English alphabet, x, y, z, right? So x is the independent because it doesn't depend on anything. There's nothing before x, but y depends on x, so it's going to be the dependent. All right. So now what is a simple regression model? So this is a simple regression model, right? So basically it says how y is related with x, right? So in this equation, you see y, x, and you see a bunch of other stuff that I'm going to talk about. But basically, it just tells you how y is related with x. So by this equation, right? So in this equation, if you know beta naught, beta 1, x, and epsilon, you would know y. Okay? And this is how y is related to x. The goal of regression is to estimate this beta naught, beta 1, and and epsilon, right? So epsilon, this is how the model looks like. So this beta naught and beta 1 are characteristics of the population. And epsilon is a random error term. So what is error? Because even if you build a more sophisticated equation, you are not going to be able to explain y completely through x. What do I mean by that? So even if you, let's say you're talking about the Butler delivery, so you cannot expect to explain the time only based on the miles, right? It also depends on maybe how the driver feels like that day, maybe the number of deliveries they were making, maybe the road conditions. And there are just infinite number of these possibilities, and sometimes it's just randomly they take more time. So the point of regression is that you cannot explain everything of the predictor variable through x, but you are going to do a smart judgment based on this model. So what we will do with regression is that we are going to estimate this beta naught and beta 1. And this is how, So this is how regression is going to work. We first focus on a model, right? The model, let's say, looks like this. Y equals to beta naught plus beta 1x plus epsilon. Now we look at some sample data, what we will look into today. Based on the sample data, we want to call something called estimate the model. And we estimate and we get the estimated equation. So this estimated equation, in the estimated equation, we're basically estimating beta naught by b naught and beta 1 by b1. Now we will have an equation. After we do regression, we will have an equation. And with that equation, now we can predict an unknown value of y given x, because we know beta, b naught and b1. I know I dumped a lot of statistical words there, but basically we will do this over and over again, right? So it will be clear. But basically what you're doing by doing regression, whenever I ask you to do a simple regression, you are looking for this equation, right? So you have to give me this equation. This is called the regression equation. And through this equation, so in this equation, you will give me a number of b naught and a number of b1. Now, once you have this number, b naught and b1, the only unknown in the equation would be y and x. Right? That means that would look like a model where if you put a value of x, you can predict the value of y. So we will do that example and see how that goes. So this is the data that we have from the Butler Trucking Company. And this data basically, of course, it's a made-up data, but here is an example of 10 assignments, right? So this is assignment number 1, one delivery person. He has traveled 100 miles and has taken 9.3 hours. So this time are in hours. Okay. So first assignment drove 100 miles and took 9.3 hours. Second assignment drove 50 miles and took 4.8 hours. Third assignment drove again 100 miles and took 8.9 miles. So as you can see, only the miles cannot explain because first assignment was also 100 miles. Third assignment was also 100 miles, but they took different times. Right? So of course, there is some error in my estimation that I'm assuming that only miles is going to predict time. Right? But we are gonna make we want to look at the best equation that Excel can give me, or the best model that Excel can give me based on this data. All right. So the first class is always the harder to get, right? And then with time, it will be easier to understand. So the first thing that we're gonna do is we're gonna look at the relationship between these two, right? So we know that, again, what is the dependent variable here? Is that miles or time? Anyone remembers? So what are we trying to predict, our estimate?
Is it time?
It's time, right? So it's time. Time is our dependent variable and miles is our independent variable, right? So you can also, just so you remember, independent variable, and this is going to be your dependent variable. All right. So the first thing, to visualize the data, to see if there is any relationship, what tool can I use to visualize the data? Can you remember your class? Like some kind of chart? Exactly. Exactly, very good. So we're gonna do a scatter plot first. Right? Okay, so rule number one in doing a scatter plot is that your independent variable has to be on the left side, and your dependent variable has to be on the right side. So sometimes I might give you a dependent variable here and dependent variable here. In that case, you have to switch, right? So your independent variable has to be on the left side because it's going to be on x-axis when you do the scatter plot. So independent variable is also called x, right? And it's going to be on the x-axis in your scatter plot. Dependent variable is called y and it's going to be your y-axis on your scatter plot. So doing scatter plots is very easy. You just want to select all of your data and we can include the titles, that's fine. You can also choose not to include the title, it's up to you, but then you have to title them yourself. So you're going to select everything and you want to just go to insert and then within the recommended charts, you are going to select right here the scatter and then just choose the first one. Okay. Again, if you're not just doing with me, that's fine, totally fine. All right, so you will probably do lots of scatter plots in this class and probably gonna be in your exam and your homework and your classwork. So it's important that we understand how to do this. All right, so with the scatter plot, I like to do a little bit of manipulation. For example, you see this plot, there's a lot of empty space, right? Right here. So before 40, there is really no data, right? So I don't like that empty space. What I would, again, these are all cosmetic, so you can choose not to do that. But what I generally like to do is I show the data that the data is all of the graph, right? So to do that, what I'm gonna do is I'm going to select just the x-axis, right? And when you have that selected, you would double click that, right? Like this. So you have to select, you have to be careful and select just the x, just those numbers, right? And you would get a format axis option, and there you see your minimum is 0. It starts from 0 and goes to 120. Now I know that there is no data from 0 to 4, so I might as well start from 40. So that's what I'm gonna do. Again, these are cosmetic, and in my videos also I do that. So again, you're not following, that's fine. So now my chart looks a little bit better because I can see the relationship in more detail, right? Then the other thing that you definitely need to do is add axis title, right? So if you give me a graph without axis title, I'm not gonna be able to give you full points for that. So we know that the y-axis is time, but there is no title for x-axis. Okay? So you gotta add axis title. To do that, there are multiple ways to do that, but you could just select on your chart and right here, just select the plus sign and just say axis title. Just click on axis tiles. Right? Once you do that, just go ahead and make your axis tile. So your x-axis is your independent variable, which is going to be miles. And your y-axis is going to be your dependent variable. Again, you probably don't need them, but I just put it there. It's going to be time. Any questions so far? Okay. So just looking at this graph, what do you think is the relationship between miles and time, and does it make sense to you? So is the relationship, do you think the scatter plot tells you an increasing relationship or a decreasing relationship? There is, there is no plus sign next to my plot. So if you don't have a plus sign next to your plot, you can select the plot, sorry, and then go to something called chart design. If you select the plot, you will be able to see chart design on top. And if you do that, you select chart design, there you will have an option to do add chart element. And there you'll have an option to do axis style. Okay. And with that axis style, you can either do vertical or horizontal, right? So you need horizontal, so you just select primary horizontal and then go from there. All right. So what kind of relationship do you think time and miles have? Is it increasing, decreasing, no relationship based on the scatter plot?
Increasing.
It's in.
Increasing, right? We see that. And intuitionally, does that match our intuition? That if miles increases, time should also increase. That makes sense, right?
It matches.
Okay, good. So every time you do a scatter plot, you should also think about what your intuition says, because your intuitions are going to be the strongest support, right? All right. So the next thing that we want to do is we want to understand the regression equation, right? So we want to come up with now the regression equation. Now, for one dependent and one independent variable, there is a very easy way to do that. It's not going to follow through your multiple independent variables, but for this time, it's going to work. So what we're going to do is you select any of the data points in your chart and you do a right click. So if you're using a Mac, it's going to be Control and right click together. If you're using Windows, it's going to be just right click. So whenever in Windows it's right click, in Mac it's going to be Control and right click together. Okay. All right, so once you do that, you'll see there is an option to add trend line. Yes, you're just gonna select that, add trend line. Again, if you're not following, that's completely fine. Like I said, I have videos, so you can, at home, you can just look at the video and do simultaneously. The same thing I do there. All right, so once you do that, you'll see that there is a straight line, right? So basically, the line of the equation is your regression equation, right? And so how do you get the line of the equation? So make sure that this linear is in trend line option, you have selected linear because we are doing a linear regression. By linear regression, we mean that the relationship between time and mile, we assume that it's linear. Right? So we're gonna select linear, and then right here, you're gonna do display equation on chart. And you're also going to do display R-square. I don't know if we will have time to get into that today, but just so that we have it for the next class. So you need to select display equation on chart and display R-square value on chart. If you select them, you will see an equation and you will see an R-square value. Works, right? Okay.
How would I display the equation again?
So you would you'd select any of the data points right here, right? And you would do right click on the data point if you're using Windows, or Control plus right click if you're using Mac. And then you would do add trend line. And then you're gonna do display equation on chart, click on that, and display R square value on chart, click on that, and make sure linear is selected in trend line option. Okay. All right. So this equation is what we were talking about all this time, right? So remember that we are talking about the model that we come up with is B naught plus B1 multiplied by X. That's our estimated model. So, and this is the equation that I get from Excel. So what is my B naught? For this problem, what is my B naught? So I just want you to compare this with this equation.
Is it 1.2739?
Yes. So B naught is the value of B naught is 1.2739. Is it clear how am I getting B naught? Because B naught is the value that is independent of X, right? So it's the value that is constant, right? It's a constant value. So what is my B1? Someone else?
0.0678.
So if you're using a Mac, your numbers might be a little different, but it doesn't matter, okay? All right. So what does this number B1 really means? And I'm gonna write it down and then explain to you. So what does this number really means? It means that if you increase 1 mile travel time, or if you increase, sorry, not one, if you increase distance by 1 mile, on average, you will take 0.0678 hours more to complete the delivery.
Is that the same thing as the slope?
Yes, it's the same thing as the slope, right? So it basically tells you what is the rate of increase of y with respect to x. It's the same thing as the slope. But in what it really means in the context is this, right? That if you increase distance by 1 mile on average, you will take 0.0678 hours more to complete. So we have if I ask you what is the regression equation, you're gonna tell me the regression equation is, what is my y? So this is your regression equation. This is the format that you're always going to use, right? So what is my y? Y is time, right? So that's your dependent variable, that's your y, right? We're gonna start with time equals to, what is my b naught? My b naught is 1.2739 plus, what is my d1? 0.0678 multiplied by, what is my x? It's going to be minus. Right, so this is your regression equation. And for all the regressions you do, I'm going to ask you to write down regression equations. And this is my model, right? Because now what I can do with this model is that I can predict and unknown assignments, how much time they will take to finish the assignment. So before I go to prediction, is there any question you have? Or maybe you want me to repeat something? So one thing about B1 is the sign of B1 is also going to tell you the relationship is increasing or decreasing, right? Because as Eric said, it's a slope, right? So if B1 is positive, that means the relationship between X and Y is increasing. If B1 is negative, and we will see examples of that, that means that the relationship between X and Y is negative or decreasing, right? So the sign of B1 is also be consistent with what you see in the scatter plot in terms of increasing or decreasing and what you come up with based on your intuition. Everything has to be consistent. Yeah. No questions? All right. So let's do a prediction. So let's understand. Let's now answer a question of predict the future. Let's say there is an assignment where the delivery person has to travel 120 miles. How much would that assignment, how much time would that assignment take, right? So let's say there is assignment 11 where the delivery person needs to travel 120 miles. Right? Now, of course, you don't have values for 120 here, right? So you can't say how much time you can take from 120 miles just by looking at the past data. You have to do some kind of analytics. So to do that, any idea how can we do that? So my question is, how much time will the person take to complete a delivery of 120 miles? Any
Just-
idea how to calculate? Sorry, go ahead.
Just plug 120 into our equation where miles is.
Exactly. That's exactly what we're going to do, right? Can you, guys, you have to really talk to me. I can't read your chats. Can you repeat how to show the miles data starting from 40 again? I missed that one. Let me finish this and then I'm gonna show, okay? So this is how you're gonna do prediction based on regression. Yes? So just because, and that's why the equation is important, because equation gives you everything. It's a model. Once you have the model, you can just fit in the data in it to get the prediction. And that's what we're gonna do. Right? So here you have this equation where time equals to 1.2739 plus 0.0678 multiplied by miles. All you're gonna do is you're gonna put 120 instead of miles, and that will give you time. That's exactly what we're gonna do. So 1.2739 plus 0.0678 multiplied by, I'm just gonna, you can just write 120 or I'm just selecting the cell, because if I select the cell, then if I change there or any other number, it's gonna give me time. So just hit enter and that would give you the time. So this is how many hours that this person gonna take. And now because of the model, the manager has an idea of how much time this delivery would take. So how about 80? Can you guys give me the number? About 80 miles.
$6.6979.
Let me see. Yep. Cool. So what we learned so far? I think we probably covered most of the things, just R square. So what we learned so far, we learned that when we have when we have a data where one variable is related to the other variable, we can first establish a relationship between those two variables and then use that relationship to predict an unknown, right? That's basically what we did. And that's basically we will be doing over and over again, maybe on a bigger data or using different techniques.
So why would the 80 in the chart be different? It's because of error?
Yes, exactly, because of error, because there are some things that you cannot explain. Okay. So one thing, how you are getting this line, right? How are you getting Excel? How is Excel getting this equation? And this will probably help your question too. So the way that Excel gives you this equation is that they try to use something called a least square method. So what they do is that they basically find the line that minimizes the total distance from all the points that you have in the data. Okay. So for example, these dots are these points, right? And they're minimizing the total. Again, it's not minimizing just the distance from one data point, right? So it's minimizing the total distance from all the data points. And that's why there is gonna be, if you want to predict an unknown number, which is already been in the data, you will get a different number than it was before, because the number will be now based on extrapolation of this equation. Okay. So, and why are these square signs? Because what it's easier to minimize squares than this distance itself, because of the convexity property that I'm not gonna go through, but it's basically doing the same thing. If you minimize a square, and if you're minimizing the original data, the distance, that's going to be the same. That you're gonna get the same line if you're minimizing the square versus if you're minimizing just the number of the distance. But basically, that's what it's doing, and that's why it's called least square method, because it makes sure that your error, the total error, is the least, and then it squares that. Okay. All right, great question. And we'll see actually, that question is very important, because we'll see later when we talk about inference and other stuff, we will see that this is important, that to understand that we might have different numbers because of error terms. But anyway, that's more on that later. The other thing that I will talk about, like maybe give me a couple of minutes, but I will again repeat that later. So one thing I ask you to also get is the R square, right? So we have a number for R square, and this is also very, very important. This is a very important matrix for understanding how good my model is. So R square is called a goodness of fit. It basically tells you how good your model is, right? How well this model is fitting your data. So all you should remember for this class is that you want a higher R square. So a higher R square is better. Just a rule of thumb, a higher R square is better. So right now, and this R square is going to be always a number between 0 and 1. So the closer it is to 1, the better fit is this regression model, which means that this model is going to be a better predictor. Right? So if we have another model, and we'll see multiple models later, where the R square is 0.8, we will say that that model is better than this model. So we just want a higher R square, and higher R square is a better model. And whenever I say better model, what I mean by that is that it's going to be able to predict the future more accurately. So that's what I mean by better model. That's what we want. So I guess that's a lot of new stuff, right? So just to summarize, what we did is we talked about regression, which shows how a dependent variable or a predictor variable, right, is related to our independent variable. So we come up with a model or a regression equation. So what we come up with is this B0 and B1 that gives us the equation. So now we can use that equation to predict unknown dependent variable. And we also learned about R squared, and it's basically a measure for a goodness of fit for the equation. So it tells you how good the equation is, how good our model is. And we always want a higher R squared. So higher R squared is better. So next class, we are going to move on to multiple linear regression, which means that we are going to have more than one independent variable. Okay? And I'll show you how to do multiple regression. It's not going to be similar to this one. So we can also only do scatter plot and trend line when you have one dependent, one independent. When you have multiple, we're going to use Excel tools, different tools for doing regression. So on Canvas, you will see there are some practice questions that I have posed. So if you want to go ahead and do those, there is also a solution just to make sure that you understand the material. If you have any questions, of course, just reach out and we can meet via Zoom, or we can meet, like, can just talk by email and stuff like that. Okay. So next, our first class assignment is going to be next Tuesday. Right. So before that, I hope you have understanding of regression, right? Because we are going to do a multiple regression assignment. All right. Any questions?
Do we need to have an understanding of SSR over SST right now, or is that extra?
Yeah, so great question. So yes, the first time I taught this class, I really went into very detail, but then I realized maybe it's not the best use of our time, given that you're probably going to use regression for more practical purposes. So those are more for your curiosity and how R squared is derived. Of course, I'm happy to answer any questions you have. But yeah, I'm not going to be asking any questions based on that, but it's just for your curiosity. So when you're reading my slides, you will see some of the slides are hidden. Yes, it's this cross sign. Those slides are only for your curiosity.
Okay, thank you.
Yes. And I guess someone had a question. If you had a question, just stay back and I can go over whatever you want me to go over again. Other than that, thank you for joining and showing me your faces, answering questions and everything. I hope I see you guys sometime soon, and see you online Thursday. Yes, same time. Okay.
Yep,
Bye.
thank you.
Thank you, Priya.
Yeah.
Thank you.
Have a good day.